Hello everyone, my name is Pragati and today we are going to dive into a very important and foundational topic in data structure, that is binary tree. What is a tree in data structure? Before we get into binary tree, let's first understand what a tree is in data structure. A tree is a non-linear data structure that represents data in hierarchical form, unlike array or linked list that store data in a linear sequence. Trees allows us to model more complex relationship. Each tree contains a node and the topmost node is called the root node. From there the data spreads out in the branches. Each node can have child node which in turn can have their own children. The real life example that may include a file system on your computer, a family tree, an organizational chart. These all have one thing in common. They start from a single root and branch out. Basically, what is a binary tree? Now that we have understand trees, let's talk about binary tree. A binary tree is a special type of tree where each node has most two children. These two children are usually called as the left child and the right child. So every node in a binary tree can either have no children, one child, or two children. Binary trees are used in many computer science applications such as searching and sorting, expression evaluation, decision making system, and much more. So the next, the basic concepts of a binary tree. Now let's go over some important terms you need to know in binary trees. That is, the first is the root node, the topmost node in a tree, and basically the node, a data element in a tree, whereas the left child and the right child, the two possible children of the node, and the parent node, the node that has one or more children, and the leaf node, a node with no children. And next, these are the core building blocks of to understand how binary trees works and how we can use them in programming. There are basically four types of binary tree: full binary tree, perfect binary tree, complete binary tree, and a skewed binary tree. First, the full binary tree. A full binary tree is a tree in which every node has either 0 or 2 children, never exactly one. The properties of full binary tree as no node has only one child, every node either is a leaf node, has no children, or exactly two children. Whereas the real life analogy, think of a family structure where each parent has either two children or none. No parents have just one child. Whereas in perfect binary tree, where a perfect binary tree is a full binary tree in which all internal nodes have exactly two children, all leaf nodes are at the same level, in the same depth. The properties are like the number of leaf nodes are 2 to the power h, where h is the height. Total number of nodes is 2 to the power h plus 1 minus 1. Height is equal to number of edges from the root and the leaf. Whereas the real life analogy for the perfect binary tree, a perfectly organized tournament. Every round has the same number of matches and all players play the same number of rounds. And the complete binary tree. A complete binary tree is a tree in which all levels are completely filled except possibly the last. The last level is filled from the left to right, and the properties are like can have 0, 1, or 2 children. Left to right filling ensures balance, used in heaps like binary heaps for priority queues. Real life analogy. Imagine people entering a bus. They fill up all the rows from left to right before moving on to the next. The skewed binary tree. A skewed binary tree is a binary tree where all nodes have only one child, either always to the left or always to the right. The properties are like can be left skewed or the right skewed. Height of the tree is equal to the number of nodes minus 1. Worst case, performance of insertion and search is equal to 0n. Behaves like a linked list. A real life analogy is like a chain of command where each person reports to exactly one person, either above right or left. And now The binary tree representation. As you can see the below code where we used to represent a binary tree. Basically, hashtag includes studio.h and hashtag includes standard library.h, whereas studio.h, this is a standard header file in C. It allows us to use input and output functions like printf and scanf, whereas standard library.h is the header used for the standard utility functions, especially memory related functions like malloc, free, etc. In this code, it is used for the dynamic memory allocation, that is malloc. And the next part is struct node int data, struct node left, struct node right. This defines a structure called node, which is a basic building block of a binary tree. It has three parts. Int data holds the value of the node, struct node left, a pointer to the left child of the node, struct node right, a pointer to the right child of the node. Think of this as one of the box node with some data inside, a left arrow pointing to its left child and the right arrow pointing to its right child. Whereas struct node, create node, int val. Basically, this says that the function definition, it creates a new node for the binary tree and assigns a value to it. Struct node is the return type. The function returns a pointer to the new node. Create node int value. The function takes an integer input called value, which will be the data stored in the node. Struct node, new node, struct node malloc size of struct node. This line allocates memory for a new node. Malloc size of struct node asks the system to reserve a memory big enough to store a node. Struct node is a typecast that tells the compiler to treat the returned address as a pointer to a node. Without this, you can't create nodes dynamically during program execution. New node data is equal to value. This sets the data part of the node to the value passed into the function. It is used to access the members of a structures through a pointer. So we are saying take this node and set its data value whatever was passed in. Next, new node left is equal to null, new node right is equal to null. These two lines initializes the left and the right child pointers to null. This means when we create a new node, it's leaf node by default. No left or right children yet. You can later connect children using new node left is equal to create node another value. And finally, return new node. Finally, we return the pointer to the newly created node. This lets us to use like struct node root is equal to create node, which creates a root with 10 value. And the next topic is tree traversal. Tree traversal is a process of visiting each node in a binary tree exactly once in a specific order. Since trees are non-linear, we need specific way to walk through the tree. That's what the traversal is all about. In real life analogy, imagine a family tree or a folder structure on your computer. You can visit the parent folder first, then the children. This is pre-order. Visit all children first and then the parent. This is post order. Or open left folder, parent and then folder. It is in order. This is all the tree traversal orders. Basically, in order means firstly it is going to visit the left, then root, then right. And whereas pre order means root, left, and right, whereas post order means left, right, and root. Let's go through for the in order traversal. Basically, in order traversal means visit the left subtree and then the root node and then the right subtree. The order is left, root, and right. The example code you can see and the applications of in-order is binary search trees. In-order traversal gives a value in sorted order used in expression trees to convert an infix notation, helpful in checking if a binary search tree is valid. Next thing is a pre-order traversal. Definition: visit the root node, then the left subtree, then the right subtree. The order will be the root, left, and the right. The code, as you can see over here, and the applications are like used in copying a tree, used to generate a prefix expressions like plus ab, useful for printing folders and structures, etc. And the post order traversal, visit the left subtree and then the right subtree and then the root node. Like basically the order is left, right and root. The applications are like used in deleting or freeing nodes, deleting children before parent, used in evaluating the postfix expression, useful in bottom up algorithm. The construction of a in order, pre order, post order trees. Uh-huh. Give me a minute only. So that's all about the in order, pre order, and post order traversal with code. In the next video, we'll see how to construct a binary tree using traversal order. So stay tuned for that. It's going to be interesting.
And here I'm going to explain about the in-order traversal. Basically, in-order traversal means where it is going to first visit the leftmost node and the root node and the right of the node. As you see the example tree over here, we can say that firstly, in-order traversal visit that the leftmost node. Leftmost node means first it is going to visit the D because it is the left of the node, and then it is going to root. The root of the D is B. Then it is going to visit the B. After B, it has to visit the right node. Then it is going to visit the E. From E, it is going to visit the root node. As it said, left part has been, we have been finished. After the left part, we have to go for root node. So that we have to go for root node. That is A. After finishing of A, we should cover the right part of the node. As we can see here, the right part of the node. So we don't have any left node, so that we can write as a right node, that is C and F. Basically, this is how the in order traversal works. You can see an video to get an idea. Now I'm going to explain about the pre-order traversal. Pre-order traversal works like first visit a root node, then visit the left subtree, and then we are going to visit the right subtree. First we have to visit for root node, that is A, then we have to visit for left subtree, that is B. In left subtree B, then we have to visit for again left, that is D. Then we have to visit for right, that is E. Then we have to visit for C node. I mean, after the left, we have to visit for the right. So that after finishing of the left, we have to move for the right. After that, so that we can write as the right of the nodes are C and F. So that basically this is how the pre-order works. And the last one is the post order traversal. Basically, it works like first by visiting the left of the node, then the right, then at last it is going to visit the root node. First, it is going to visit the left subtree, that is B, and then it is going to visit the right subtree, that is C. Within B, first it is going to visit the D, and then it is going to visit the right of the B, that is E. Within C, that is going to visit the F first and then the root C. Finally, after finishing the left and the right, it is going to visit the A. Finally the order will be D, E, B, F, C, A.
Applications of a binary tree. Binary trees can be used in an expressions tree, binary search tree, heaps, trash and humans trees, and syntax trees. Basically, they can also used in expression trees. Heaps means priority queues, whereas decision trees, syntax trees, file organization, networking routing, etc. And so that we have complete look at binary trees, that they are, how they work, how we traverse them using pre-order, in-order, and post-order method. We also saw some powerful binary trees are in real-world application from searching and sorting of two compilers, AI, and even the file system.